Have you ever looked at Docker and thought, this is brilliant, but what I actually want is something that feels more like a proper computer without being as heavy as a virtual machine? Well, that's where LXC comes in. But what the heck is LXC? Welcome to Foxy's Lab. I'm Foxy, and in this series I explain complex smart home, IoT and home lab concepts in a way that makes sense. In this episode we're talking about LXC, the original Linux container technology that Docker was built on, and a tool that's still going strong for anyone who needs something a bit more substantial. So, go grab a coffee, I'll get one too, and then we'll get into it. LXC stands for Linux containers. It's a lightweight virtualization method that lets you run multiple isolated Linux systems called containers on a single host, all sharing the same kernel. Think of LXC as the middle ground between a full virtual machine and a Docker container. It's heavier than Docker because each container behaves like a complete operating system. You get the full init system, you can SSH into it, you can install whatever you want, but it's much lighter than a VM because you're not virtualizing the hardware or running separate kernels. Basically, if Docker containers are like camper vans, or an RV if you're an American, fast, single-purpose and easy to move, then LXC containers are like static caravans. I think Americans call them trailer homes. Still portable, but with a proper kitchen, bathroom and enough room to actually live in. Here's a quick history. LXC emerged around 2008 from Linux kernel development work, with Daniel Lazcano as a major contributor, and it quickly became the foundation for Linux containerization. It built on earlier kernel features like cgroups, control groups, and namespaces, which allow process isolation without needing full virtualization. For years, LXC was the go-to solution for anyone who wanted lightweight virtualization on Linux.
It's good to be the king.
Then in 2013, Docker came along and actually used LXC under the hood, at least at first. Docker eventually swapped out LXC for its own runtime container called libcontainer, which later became runc, but LXC carried on independently and is still actively developed today. Nowadays, LXC is often used alongside LXD, a more user-friendly management layer built by Canonical, the company behind Ubuntu. Together, they offer a powerful system for running lightweight Linux environments that feel like full machines but without the overhead of traditional VMs. Like any good tech, LXC has its own set of jargon, so let's break it down. A container in LXC is an isolated user space environment. Unlike Docker containers, which usually run a single process, LXC containers can run a complete operating system with its own init system, services, and networking. You can treat it almost like a virtual machine. LXD, sometimes pronounced as LXD, is the management daemon for LXC. It adds a REST API, image management, snapshots, live migration, and a much friendlier command line interface. If LXC is the engine, LXD is the dashboard. Most people these days use LXD rather than raw LXC, just because it's easier.
Let's not make this any more difficult than it already is.
cgroups, or control groups, are a Linux kernel feature that limits and isolates resource usage for groups of processes, things like CPU, memory, disk I/O, that sort of thing. LXC uses cgroups to make sure that one container can't hog all the resources and starve the others. Without limits, a container can consume excessive CPU or memory. Cgroups let you set those boundaries. Namespaces are another kernel feature that provides isolation. They separate things like process IDs, network interfaces, and mount points, so each container thinks it's the only thing running on the machine. Privileged versus unprivileged containers is actually an important distinction. Privileged containers run as root on the host, which gives them more power but also more risk. Unprivileged containers use user namespaces to map container root to a non-root user on the host, which is much safer. Always use unprivileged unless you have a really good reason not to.
That's good advice.
Images are pre-built templates for containers. LXD is an image server with official images for Ubuntu, Debian, Alpine, and loads of other distros. There are even some for apps, although the ecosystem is nowhere near Docker Hub. You can launch a fresh container from an image in seconds. Snapshots let you save the state of a container at a specific point in time. They're perfect for testing. Make a snapshot, break things, roll back, repeat. Profiles are reusable configuration templates. You can define things like network settings, storage, or resource limits in a profile and apply it to multiple containers. Super handy for keeping things constant. LXC is popular in a few different circles. Home server enthusiasts use it to carve up a single machine into multiple isolated environments. You might run your media server in one container, your file server in another, and your development environments in a third, all without the overhead of full VMs. Proxmox users are probably already familiar with LXC because Proxmox has first-class support for LXC containers alongside general virtual machines. When I've used LXCs in the past, this is how I've used them. In fact, for a while I thought LXCs were just a Proxmox feature, as I'd never heard of them used outside of that context. It's a brilliant way to maximize resources on a home or small business server. Developers and sysadmins often use LXCs for testing and staging environments. Spin up a clean Ubuntu container, install some software, test it, then destroy it. No muss, no fuss.
No muss, no fuss, not a single cuss.
Hosting providers sometimes use LXCs to offer lightweight VPS-like services. It's more isolated than shared hosting, but cheaper and faster than full virtualization. LXC really shines when you need something that feels like a full Linux system, but don't want the resource overheads of a VM. It's perfect for long-running services that need persistent state, multiple processes, or a traditional Linux environment. LXC is not Docker. Docker is designed for microservices, usually a single process and ephemeral stateless workloads. LXC is designed for system containers, multi-process and persistent stateful environments. Different tools, different jobs. LXC is also not a full virtual machine. You can't run Windows in an LXC container. In fact, you can't run a different kernel to the host. You are limited to Linux, and you're sharing the host's kernel, which means it's got less isolation than a virtual machine. LXC provides isolation, but it's not the same security boundary as a full VM.
There a key to this lock?
If you need proper hardware virtualization or true isolation, use a real virtual machine solution instead. If you're enjoying this video, give me a like and hit subscribe. Are you using LXC in your home lab? What's your setup? It's Proxmox, isn't it? Drop it in the comments, I want to hear what you're running, especially if you're going to surprise me and say it's not Proxmox. If there are any topics you'd like me to cover in a future What the Heck video, let me know in the comments and I'll stick it on the list. Alternatively, you can also hit me up on our Discord server, link in the description. LXC is powerful, but there are a few things that can trip you up when you're getting started. Welcome to the gotchas. Please keep your hands where I can see them. Networking can be tricky. By default, LXC uses a bridge network, but setting up advanced configurations like VLANs on multiple network interfaces will require a manual setup and a solid understanding of Linux networking. It's not impossible, but it's definitely steeper than Docker's networking if you need anything beyond the basics. Unprivileged containers can be finicky. Some software doesn't play nicely with user namespace remapping, especially older or poorly written apps. If something refuses to work in an unprivileged container, you might have to go privileged, but do it carefully and understand the security implications. A good rule of thumb is to follow the principle of least privilege, which I've mentioned before on this channel and will probably mention again. Only give a container privileges if you are sure that it needs them. Sure, it may fix the issue you're having, but if you don't know why you did it, you might also be making a security nightmare for future you.
That's their problem.
Containers are not a hard security boundary. Just like with Docker, LXC containers share the host's kernel, which means they're not as isolated as VMs. If you're running hostile or untrusted workloads, use a proper virtual machine or just run it on bare metal. Storage permissions can be confusing. Because of the user mapping and unprivileged containers, file permissions on shared storage can get messy. It takes a bit of fiddling to get right, and you may find yourself Googling permission errors more than you'd like. Don't be ashamed, it happens to the best of us. LXC does not have the same ecosystem as Docker. There's no equivalent to Docker Hub or Docker Compose. You'll be building your containers more manually, which gives you control, but also means more work up front. If you're used to Docker's convenience, this can feel like a step backwards. Proxmox does have LXC templates, which can be very handy, but it's still nowhere near the user friendliness provided by Docker. Rule 1, use LXD, not raw LXC. Unless you're a masochist or doing something very niche, LXD makes everything easier. Better commands, better image management, better everything. LXC and LXD are mostly CLI driven. Some third-party dashboards and GUIs do exist, but they're optional. That said, if you're using Proxmox, you already have a brilliant management interface for LXC built in, so you won't need LXD. Proxmox handles all of that for you. Rule 2, try to stick to unprivileged containers. Privileged containers are a security risk. Yeah, unprivileged containers can be a bit more awkward, but it's worth it for the peace of mind. If you know what you're doing and you're sure you have a need for them, then feel free to ignore this rule, but don't break it otherwise. I'll know.
He's always watching.
Rule 3, use profiles. Define your common settings once in a profile and then reuse it. It keeps your setup consistent and saves you from typing the same commands over and over again. Again, if you're a Proxmox user, you won't be using LXD profiles, but the principle still applies. Rule 4, take snapshots before making changes. Snapshots are fast and they can really save you bacon when something goes wrong. They don't take much resource either, so honestly there's no good reason to not do this as a rule. Get in the habit of snapshotting before making updates or config changes. Rule 5, document your containers. It's easy to forget what each container does or how it's configured. Keep notes, use descriptive names, and maybe even keep a little readme somewhere. I often use Notion to document things like this on my home lab, and it's saved me from headaches more times than I can count. So that's LXC, the OG Linux container technology that's still relevant, still powerful, and still the perfect choice when you need something more substantial than Docker, but lighter than a VM. What the Heck is an ongoing series where I explain the ins and outs of tech. I try to post a new video weekly, usually on a Monday, so if you want to be notified when the next episode drops, hit the bell, and YouTube will make sure you're kept in the loop. If you haven't already, go check out the What the Heck is Docker episode, since I just mentioned it about a million times in this video. It's definitely worth watching to understand the difference between the two. Or if you're running Proxmox and want to learn more how LXC fits into that ecosystem, I'll be covering Proxmox in a future episode, so make sure you subscribe so you don't miss out. You can also check out my full What the Heck series right here.